Morning, guys. Happy Monday. How's everyone doing? Go ahead and type in the chat if you're here. Looks like I have a couple viewers. I'd like to see who's here, though. Guessing Liberty and Rachel. Good morning, Rachel. How's your weekend? It was good. We saw my cousins in Lakewood. Oh, cool. That sounds like fun. Did you guys just get together and like hang out, or was there like a birthday party or something, or made the long trek out to Lakewood? What was that? Probably like 40 minutes. Nah, just hung out. Nice. I'm sure that was kind of good. Yeah, it's I think more people are starting to branch out just a little bit, but I don't know. I think now people are slowly starting to get back to normal. I think this starting today. I know like a lot of my friends and like people I know are going back to work, like officially back to work, which is good. It means like we're kind of making some progress. So I think if you're, I don't really know how it's classified, but I think most people are allowed to go back to work. Obviously, not schools and some places like that, but most people are allowed to go back to work as long as they're following all those rules and stuff. So I think with that happening, I think slowly people socially are starting to probably get it together more. Just not in like a public setting. It seems like it's gonna be more of a casual, like, visiting someone at their house or something like that. My weekend was all right. If anyone's curious, cooked a really good meal. Um, Hung out with some people. It was good. Good weekend. So it looks like there's two people in here. I don't ever know though. It says like it tells me viewers, but half the time I think I'm sitting here alone and it says I have a viewer, so I don't really know how it's judged. But um, maybe I'll just ask Rachel. Do you know if Liberty's watching or tuned in or working on it or anything? She's usually here. Switch over to this. Oh, okay. Good. All right. So that was actually gonna be the first thing I was gonna address, but I don't know if anyone's listening. I know obviously you are. So yeah, when you get a chance, submit that 2018 FRQ. You don't have to do it like don't like if you didn't do part of it, the assignment, like don't panic and like try to submit it. I'm not gonna mark anyone late, grade or anything. I think I forgot to tell you guys to submit it because I think we like probably finished it during class one day and we just never submitted it because I had to go over it or something. Whatever it may have been, I don't remember. But when you get a chance, just try to submit that so I can put a grade in for Power School for you. And just so you know, Rachel, and if anyone else is listening, the way I graded the last one, the 2017, and the one and this is how I'll grade 18 and 19 as well. I'll grade the assignments you do for homework for accuracy. So I'll look over those parts. Whether it's like 2018, 1, 2, 4, and 5. Like if those are the ones you did for homework, those will be the ones I grade. The other ones will get a grade too, but it'll be completely off of completion. So that's why I'm asking you to submit the whole assignment, because then I'll just look to see if you have a picture submitted. So I don't have to go through and like check everything. Again, the reason being is because I kind of just figure if that's the ones we do in class, I'm always like available to talk to during it. So if you guys ever have questions while you're going, I usually review the answers that day as well, so you can like check your work and everything. So that's kind of why that's why I'm doing that way. So just so you know, if you were curious on what the grade for the 2017 was, like how I came to that and everything, that's what I did. So the homework stuff I'll grade like as if it was an AP test. The stuff we do in class, I just give you credit for. Okay. I guess I'll keep going. So this is our schedule. You've probably seen it by now, or taken a glance at it. I think I posted it yesterday, like afternoon. But just to lay out, so most importantly, obviously, is we have that test. The test is next week, right? By the way, Rachel, do you guys have any tests coming up this week? Is there any ones that like you're studying for, multiple ones maybe that you have coming up? Curious to know. But for our AP test, the BC, it is going to be next Tuesday. What we'll be doing, obviously, we're going to continue reviewing. So Monday and Wednesday are going to be the same like we've been doing. So we're going to finish the 2019 practice today. It shouldn't take too long, and then you can get started on the homework, which you might be able to get another question done from that. We'll see the pace we're going at, but that's the 2016 FRQ. So the one that we're going to do, this 2016 one, is like the actual FRQ that was used in the year 2016. So what all the BC kids got that year, these are all the questions straight from that. So the ones we've been doing have been practice exams. This one is a legitimate exam. So it's actually the 2016 exam. So we're going to work on that. Let's take a look at types of questions. And you'll notice that they're extremely similar to the practice exam. So it's the same type of questions. And we'll be doing that for the rest of the week. Let me read what you said. The Calc one is our first one. Okay. Then all of us in BC have English Wednesday and Physics Thursday, and then Stats have Final Friday. Yeah, I knew Stats was like oddly late. Like, that was like one of the last AP exams that's like given, which I thought was interesting. But okay, so you guys have a very busy week next week. In terms of English, I don't know how much preparation goes in English. I know it's an FRQ, so I'm guessing you probably have to obviously you had to read all the books, but I don't think anyone plans on cramming reading the books in the last, for the next week. I don't know. I'm not really sure how you guys operate with that, but hopefully that, I don't know how much prep that takes. I don't know, physics obviously is going to take some prep, so. The reason I'm asking is because I just wanted to make sure that I'm not, I'm going to give you enough time where you can prepare for any other AP tests you have as well, not just BC, but. With that being said, though, kind of transitioning into Friday, I'm not going to give you homework over the weekend. So I figured, because my reasoning was this, I thought, like you just said, I was like, they might have some other AP tests next week that they have to study for, prepare for, other classes might be giving them work to do. And I don't really want to just overload you guys. So I'm making Friday. I'll still obviously be here, so I'll be on my stream. You guys can hop in and ask any questions you have. But my goal is for this weekend is to do what I say is final prep for the AP exam. Final prep is just taking the demo test, which is offered today, so that opened up today. So going into College Board, taking a demo test, making sure that worked out, the pictures submitted, like you have everything planned for that. Making sure you have all the documents you want to use ready to go. Looking at those documents, so call it studying, however you want to look at it. But another part of that final prep is to just understand where everything is in your notes. Understand, whether that means putting sticky notes on each chapter, however it may be. Organize your notes so you are available to access them very quickly if you need to. Figure out what you're going to do with the cheat sheet, I guess you can call it. Maybe make your own cheat sheet. If you're like, hey, I'm really good at like the integrals, I'm really good at derivatives, that stuff's easy money. I'm not good with series. I always forget what the series tests are. I can never remember what the stipulations are on them. I need that. So maybe you want to make a sheet where you just write just those, and so you have that next to you the whole time, and like that's something you can look at right away. So that's what my final prep for AP exam means. But I'm gonna post a document with some suggestions on what that means. So I'll the stuff I've been saying I'll put in a document form, and I just want to kind of guide you guys as a way to prepare. And then I'm also gonna put out a form in Google Classroom for you guys and AB, and that form is going to be just asking you what you want to review. So that's another thing I want you to do this weekend is I want you to think about, okay, Monday is the last day I can talk to Mr. Harris. I mean, the last day I'll be like live to answer like live questions. If you have an email, obviously I'll answer, but that's the last day that I'll we'll talk. Well, actually, no. I mean, your test is Tuesday, so unless you have a question before 2 p.m., I can answer. But anyways, that survey will literally just be like, hey, on Monday, what do you want to review? And if you guys can get that to me early enough, then I can plan and find something, quickly enough where if the whole class all says like, hey, Mr. Harris, ratio test, got to do it. No clue what's going on there. Then I can be all right. Let's focus on that Monday. And so yeah, make sure just look out for that later this week. Okay, so I think that's all I got to say, Rachel, for that stuff. If you have any questions, go ahead and type that in the chat. If you are good, we're going to finish up the 2019 practice exam. So we're going to do question 6. You can see on my calendar, don't do D. D is using alternating series error bound, which will not be on the test. So we're going to nix that for today. So just A through C is what we'll focus on. All right, I'm going to go blow my nose. I'll be right back. How's the weather today? Ooh, a little chilly today. And tomorrow. Dang. This weekend was fantastic. Beautiful outside. I was hoping maybe we were taking a turn. We're going to be in the 60s and 50s consistently. A little bit chilly this week, though. I got burnt yesterday. It was amazing. Very rarely do you see someone send a message that says they got burnt and they say that it's amazing at the end of it. I know what you're saying though. Like right now, I think it'd be great to get sunburnt. I've been thinking about like just going one of those days I was thinking about just going outside and just hanging out just to get a little bit of a tan. Probably get burnt too, but feels like it's been so long since I've seen the sun. I was like, I need to go out and get the vitamins. So Rachel, when you're done with 6A through C, let me know. Obviously, if you have any questions throughout, let me know. But if you finish those up, we can stop and I'll go over them and then we can move on from there. But For part C with the p-values, part C with the p-values just be any p greater than 1. Any p greater than 1 because it would be a p-series, or does the fact that there's a negative 5 on top this time change the location? Rather than the positive 5 we had canceled out. So it does change. You're right. Like, your answer ends up being correct. It does change a tiny thing. So the only thing it does change, Rachel, is the numerator. Once you simplify that out, so once you plug in all the different pieces and you simplify it out, your series should read the series from n equals 1 to infinity of -1 divided by n to the p. So essentially the -5, all it changed was it turned the numerator into always -1. That doesn't change your answer, though, because that just makes whatever value it converges to negative rather than positive. So yes, you're correct. Just make sure that you show that step. Okay. All right. So let's take a look at the answers. All right. So they give you this series, and the series has a bunch of different variables. We have an x, we have an n, we have a p. So part A says, given that p equals 3 and x equals 8. So the first thing you wanted to do was rewrite the series, replacing p with 3 and x with 8. So you got to start there. And it says that the series converge absolutely, conditionally, or diverge. So the steps you want to take are this. First things first is let's simplify. So you want to write out the series, replacing those variables. And simplifying, you should end up with a series from n equals 1 to infinity of -1 to the n plus 1 on the numerator divided by n cubed. So you should have gotten to that point. That series alone is going to be convergent. Why do we know it's convergent? Because alternating series test. So you use alternating series test, you know the limit of the non-alternating part approaches 0, and we know that the non-alternating part is also decreasing. So based off of those facts, we know it converges by alternating series test, so we know that we can eliminate diverge for being an option. But we have to figure out, is it absolutely convergent or conditionally? To find that, you just take the absolute value of the series. So you take the absolute value of -1 to the n plus 1 divided by n cubed, which turns it into just 1 over n cubed. And that's convergent by p-series, because 3 is greater than 1. So since the absolute value is convergent and the normal series is convergent, that means that the total series is absolutely convergent. So 6a, at the end of the day, the answer is absolutely convergent. Part B, same exact thing, okay, except this time p equals 1 and x equals 8. So this is the same process. Everything I just said, you repeat that process. This time, though, you find that the series simplifies down to -1 to the n plus 1 divided by n. So instead of divided by n cubed, it's just divided by n. That series alone will actually converge. It converges by alternating series test. So we know that for the answer for B is not diverge. We just have to prove is it conditionally or absolutely convergent. Well, we take the absolute value, and you get a series of 1 over n. That's a harmonic series. Harmonic series diverge. So since the absolute value diverges, that means that it's conditionally convergent. Okay, and then part C, similar scenario, just says, except this time the only thing we're given is when x equals -2, what happens with p, or like what values of p makes it converge. So we plug in -2 for x, simplify that down. Like I said, you should end up with a series of -1 over n to the p. And like I said, the negative just makes your whatever it's converting to a negative value. It doesn't change anything else because it's not alternating. It's always negative. So at the end of the day, it's asking the question, just asking what's the definition of the p series. Because it's saying if you have a series of 1 over n to the p, what does p have to be to converge? And that's just the p series, which states p has to be greater than 1, like you said in the chat. All right, go ahead and type in the chat if you have any questions on that. Yeah, good. All right. I agree, Rachel. I thought this one was kind of easy. I feel like if this was on the test, I think people would be pretty excited. Not too much work and not overly complicated. All right, so the next assignment, you might as well, it's really up to you. You don't have to, but if you have nothing else to do right now, I'm here for the next 25 minutes for BC, so you might as well get started on your homework if you'd like. I posted to Google Classroom, so you can check that out. It's a PDF, like I said, it's a 2016 free response questions. Yep, no problem, Rachel. Yeah, no problem, Rachel. All right, you said you finished all of 1 except part D. All right. So, number one. Number one, you could use a calculator. So, graphing calculator was required. This one has to do with some Riemann sums. So, the first question wants you to estimate r prime of 2. Whenever you think of estimating a derivative and you're given a table, we want to take average rate of change. That's the best way we can estimate it. Right, because it's r of t, so to take the derivative of r of t, we have to use the table. So we take an average rate of change. The best estimate we can use is the points 1 and 3, because 2 lies between 1 and 3. So we want to take r of 3 minus r of 1 divided by 3 minus 1, and you end up getting negative 120 liters per hour squared. Again, negative 120 liters per hour squared. Using left Riemann sum with 4 subintervals. So you basically want to just break up the subintervals, find the width of each, and find the height of each. Add those together, and you should have gotten 8,050 liters. Again, 8,050 liters. You can see that r of t is decreasing over time. So whenever we're estimating a function that's decreasing using a Riemann sum, it's always going to be an overestimate. So 8,050 liters overestimate. Part C wants you to use the answer for part B to find an estimate of the total amount of water. Well, the total amount of water in the tank is going to be calculated by taking whatever the initial amount is, plus whatever is entering the tank, so whatever amount of water is being pumped into the tank, minus whatever number of liters is being removed from the tank. So it's the initial plus pumped in minus pumped out. So to find the initials given to you, to find the amount that's being entered, you would take the integral from 0 to 8 of w of t, because w is representing the rate at which water is being pumped in. So in order to go backwards from a rate back to just the amount being pumped in, we take an integral from 0 to 8. And then we're using our estimate from part B as the amount that's being pumped out. So that's 8,050. Put all that together, your final answer for C is 49,786 liters. Again, 49,786 liters. Rachel, just so you know, for D, I'll write it on my piece of paper here. Real quick. D, basically the question is asking for this. When is the rate of change of it entering equal to the rate of change exiting? That's, at the end of the day, that's what we're looking for, to put it very, very bluntly. So I can rewrite this, and this is going to be useful to you when you go through D, is I can rewrite this as this equation. So treat this as an equation, right? I can subtract RT from both sides, and I get WT minus RT equals 0. Your goal then is to basically figure out, I'll let you work through it, but your goal is to use intermediate value theorem somehow with this information. We have to use intermediate value theorem. So we have to prove that at the beginning of the time, it's here. At the end of the interval, it's here. Does that mean it has to hit 0, or they have to be equal at some point in that interval? Yep, no problem, Rachel. Have a great rest of your day. Calc AB, how's everyone doing? Hopefully you guys are doing good. Go ahead and type in the chat how your weekends were. Good morning, Haber. Morning, Katie. Morning, Andrew. Morning, Peyton. Morning, Alexis. Peyton says tired. Jasmine, good morning. Pretty good. I actually have some energy. I think I got a good night's sleep last night, which helps. So I feel pretty good actually today. Morning, Alexis. Morning, Brandon. Mine was good. Good. Good to hear. Anyone do anything interesting? 7. I forget. Install my grandma's shout-outs there. Nice. That was nice of you, Katie. Sounds like hard work, but I'm sure it's probably good. It was a beautiful day. That's for sure. This weekend was fantastic weather. It looks like it's supposed to be like not as great this week. A little chilly, a little bit rainy. Not quite as that deal. I was hoping maybe based off of this weekend, I was like, man, if every day is like this, it makes things a little more manageable. But I'm sure it'll be snowing in a couple days. You know how it is, Ohio. I'm sure she was very appreciative of that, Katie. Hopefully you didn't get too close to her. Got to be careful around some of the elderly. So guys, go ahead and get the calendar out. I'm going to talk about it. Go ahead and get your calendar out. You don't necessarily need to get this assignment open. I've graded most people's. If you already turned it in, I graded it. I just wanted to talk about something real quick from this Unit 7 assignment. Something that I was noticing with people. I'm sorry, I have the wrong calendar up. I was going to say, I thought I did that. Not Unit 7. Hold up. Back up a little bit. Get the most recent calendar out. Here we go. All right, so get the 2017 FRQ up and open. That's where we'll start. Okay, we're going to start with 4. So, hopefully you have the calendar up, you got the assignment up, your work is out. Make sure all that is true. And I'm going to look at number 4. So, like usual, I'm going to give you the answers to 4. So I'll give you the answers to this assignment. Check your work as I'm going through. If you have any quick questions, I'll review them. Not too long, but if it's reasonably timed, then yes, I'll go over them. check something real quick. All right, so happy Monday, guys. Hope everyone is doing good. I had a decent weekend as well. I made wings for myself yesterday, which is probably my favorite food. My parents actually got me, I don't know, it was a while ago. I got some like sauce from Buffalo Wild Wings. So I put some of that, made some wings, had a little veggies. It was delicious. Favorite food. So I was very excited about that. It was, big highlight. Watch the Jordan documentary. If any of you guys who are interested in basketball, I highly recommend on Sundays. They have a Michael Jordan documentary. It's very, very good. If you are interested in basketball and you haven't seen that yet, I highly recommend it. Yeah. So yeah, let's get started. We got a big week ahead of us. So if you can see on my calendar, obnoxiously put is next week Tuesday. That's the big day. Hopefully it's been circled in your calendar since it was released. Hopefully you guys are well aware. From what I can understand, this is going to be your first AP test for this year. Some of you probably maybe your first AP test ever, but I think this is going to be the first one you take. Maybe you can in the comments go ahead and correct me if I'm wrong, or in the chat correct me if I'm wrong. But from what I understand, this will be the first one of this year. So it's next Tuesday, guys. That's I've been saying that it seems like it's a while away, but it's really close. And now hopefully it's sitting with you that you have a week to prepare. Okay. Not meant to scare you though. Government is Monday. Okay, so you guys do have one before. Okay, so government you guys will take then on Monday, which means that you got a crazy next week. I know government then Monday. Ours is Tuesday. I don't know about psychology. If any of you are in psychology, I'm not really sure about that one. Don't know when that occurs. If you're in stats, which very few of you are, but if you are in stats, that one's not for a while, so you don't have to worry about that. I don't know if English, I don't know if you guys take any English or anything. I know that's next week at some point. So make sure you obviously know your schedule. But I'm good to know that government's Monday, which means that you guys are going to be putting a lot of time into that as well. Let me break this down for you and kind of walk you through what I'm thinking. So first of all, the Monday and Wednesday, this Monday and Wednesday is going to be, we're going to keep doing what we're doing. I'm going to keep cranking out problems for you guys to practice with. The more problems I can expose you to, the more you'll see, hopefully the better you'll do. So today we're going to review very quickly the homework from Friday. I'll give you the answers. And then we're going to start on number 6. Okay, maybe I don't need to go like super, super quick. So I'll probably go over some stuff for question 4 if you guys have it. But then we're going to go and do number 6. That'll take us to the end of class. Your homework tonight will be to do questions 1 and 2 from the 2018 AP exam. So it'll be the 2018 one, 1 and 2. You'll skip part C for question 2. So make sure you guys take a note of that in the calendar. Skip part C for question 2. All right, Wednesday I'll give you the answers to those 2 homework questions. So you have them. Maybe go over a partial part of one or at least a little bit. And then we'll do some more practice problems in class or in the stream. And then you guys will have homework, blah, blah, blah. And then Friday, as always, it'll be review day. So any question from basically the 2018 FRQ, Friday, you guys can ask that. So we'll spend all Fridays kind of reviewing that assignment, 2018 International Practice Exam. So a big thing, though, Friday for homework. So over the weekend, I'm not going to give you homework. Like, I'm not going to say, like, oh, do number 6 of this FRQ. Like, I'm not going to do that because I'm aware that you guys have other AP exams to prepare for, number 1. Number 2, it's just more important to me that at this point, like, the way I look at it, and I've looked at this always for tests, if you need to cram, like, seconds before the test or you're, like, panicking, that means you weren't prepared enough in the first place. So the way I see it is by this weekend, you should already be like, if you had to take the test right now, you could. It shouldn't be like, okay, you got to panic to study and cram right before. That's not what I want. And if you're feeling like that, then this week is a super important week to get you on pace. But anyways, the reason I'm saying this because this weekend I want you to use as what I'm just going to call final preparation for the AP exam. I'm going to post, you can see, you can look at a document. I'll post a document in Google Classroom once I get that all organized. And this document will lay out what that means to get prepared. I don't mean like, okay, study chapters 1 through 7 in your book. That's not what I mean to prepare for AP exam. This is like, has my internet been okay? Can I log into College Board whenever I want with no problems? Did I take the demo test? So today they released for your AP, you guys can go into AP Classroom and you can take demo tests. It doesn't have to be just for calculus. It could be any subject you're taking. You can take a demo test. And that test will just help you practice what it looks like, the process of taking the test. So when you actually do it next Tuesday and Monday, you're not going to be like, what the heck is going on? This is not what I thought I was going to see. If you take the demo, you'll be completely comfortable with what to expect. So highly recommend to do that this week. But if you hadn't done it this week, then I'll mention that to do that for sure. So something like that. Getting your materials organized. So if you have notes that are out of whack, notes that you have no idea where anything is, getting sticky notes and labeling them. Everyone's different. Making a key for yourself. Maybe you want to make like an index so you know exactly what page to turn to if you're looking for certain books, certain notes. Like whatever it may be, you have to have those in order. Because if you're scrambling to look through your notes and find like an idea or a topic, it takes you 10 minutes and you only have 15 minutes to do the problem, you do the math, right? Not good. Not going to help you out. Not going to work. You can't be flipping through your notes like crazy. If you need to look at your notes and you know like, oh, shoot, I don't remember this, I need to look at my notes, you better know immediately where to find the notes. So like if it's on differential equations, you're like, okay, it's a question of differential equations. I'm not exactly positive on how to take the derivative using implicit differentiation for this. I'm having a little brain fart. Let me fly through my notes. Okay, so you should already know, all right, that's on this page of my notes. Bam, get there, look at the question, takes a minute, you're ready to go. That's what I need you guys to be at. If you don't, and you plan on just like, oh, I'll just flip through my notes until I find something, it's not going to work. I promise it won't work. So that's going to be a part of preparation too. Along with the notes is that cheat sheet I sent you. Make sure you have that if you like it. You guys can find other ones. That's the one that that's my favorite that I found. But yeah, you can look online, whatever works for you. You can even make your own if you really. That would be very good idea, is to make your own cheat sheet, your own like little calculus Bible or calculus guide that is personal to you and it focuses on things that you think are important or the way that you look at things. That's going to also be huge. Like you got to make sure that if you plan on using like my guide or you want to use your own guide, whatever cheat sheet on the test, if that's your plan, you better be very, very comfortable with whatever it is. You better know where the formulas are, and you better be able to like find them very, very quickly. Because if you don't, again, and you have to flip through the whole thing over and over, it's going to take 5 minutes that you just don't have. You just don't have that time to give up. So organizing materials is really the biggest part of this final prep. Making sure that you have a plan, creating a plan for yourself. No one going in like, okay, I'm going to have my notes out. I'm going to have Mr. Harris's cheat sheet out. I'm going to make sure my calculator's charged. Like have an exact plan of how you're going to attack this test on Tuesday. And then on top of that, the final preparation obviously is you still want to look at materials. So if you're someone who's very confident, you feel good, then you do what you think. It's all personal. Hopefully you're not cramming, but if you know that you know nothing and you're going to fail, then yeah, you're going to need to cram. You're going to need to put a lot of effort and time into it. And that's going to be more on the content side. My intention is that hopefully by now the content is actually not too bad. That's not the part that you need to go crazy about. So that'll be a part of the preparation too, is just looking over materials. Specifically, I'm going to be putting out a survey. So next Monday is the last day I'll see you guys in this stream format. So obviously I'll answer emails up until your test, but last time I'll see you is Monday. Not actually see you, so sad. Next time I will be available to you to talk to live will be next Monday. It's going to be a complete review day, so we're going to just take an hour and I'm going to review anything you guys have. It's not going to be like, I'm not going to be in chat and just be like, okay guys, just type in chat what you want to talk about. And someone's like, oh, Mr. Girls. Like I'm going to need more than that. I can't just like pull stuff out of thin air. I want to prepare for it. So to prepare for it, what I'm going to do is I'm going to have a survey out sometime this week. The survey will literally just be like, what topics would be most useful for you to cover next Monday. So like the last minute cram, like what do you feel least comfortable with? And I'll just take the total. I'm sure the people who fill out the surveys are just the people who are listening to me right now. So I'm going to take all the totals. I'm going to personally pick what I think is going to be most important. If you guys ask me like a question about a theorem we talked about once and I don't feel like it's going to be worth our time, I won't do it. So don't expect like everything you say to be reviewed. I'm going to try to pick out things that are going to be the most important. So look for that survey. I'll keep you updated. It'll be in Google Classroom. And throughout this week, keep in mind, look back in your materials. Keep in mind really what like units you struggled with, whether it's differential equations, limits, derivatives, integrals, whatever it may be. Keep that in mind and let me know. Okay, I think that covers the week and it covers everything I want to talk about for Friday. Once Friday comes and the week progresses, I'll talk about it more and more. So it'll be hopefully ingrained in your brain of what my intention is. All right, please ask questions in the chat if you have any. I'll be looking at that, but if not, I'm going to go over number 4. So this is a 2017 FRQ, number 4. Just give you a minute. Okay, hopefully you have the workout now. Assignment's open. So we're given a table with x and f prime. First part says use a midpoint Riemann sum. So midpoint Riemann sum, that's the biggest information we need. And the intervals is 3. So there's 3 subintervals, midpoint Riemann sum. So first of all, you want to break it up into 3 intervals. So it looks like the interval is going to be 0 to 2, 2 to 4, and 4 to 6. The midpoint of each of those is going to be 1, 3, and 5. So what we need to do is we're going to find f prime of 1, f prime of 3, and f prime of 5. That's going to be the heights of each rectangle in our Riemann sum. The width of each interval is going to be 2. Okay, so the question though, it says use a midpoint Riemann sum with 3 subintervals of equal length indicated by data in the table to approximate the value of f of 6. We're approximating the value of f of 6. We're given f prime. If we're given f prime and we want to approximate an original function value, we need to take an integral. So you would take an integral from 0 to 6 of f prime. And that representation, that integral of 0 to 6 of f prime is what it's using the information from the table. So your width of every single interval is 2, so it's going to be 2 times 3.5 plus 0.8 plus 5.8, which gives you 20.2. So that means using the fundamental theorem of calculus, 20.2 will be equal to f of 6 minus f of 0. You solve that because we know what f of 0 is. It's given to us. And you end up getting your answer as 40.2. So your answer to 4A is 40.2. Okay, so for part B, a couple things we need to take into account. So we know that f prime of x has to be less than or equal to 7. That's given to us. So in the original question, it tells us that f prime of x is less than or equal to 7. Which means that the integral from 0 to 6 of f prime of x is going to be less than or equal to 6 times 7. How do I know that? Well, because I know that I have 6 subintervals. And I know there's a max height of 7 for each endpoint. So essentially what I'm doing is what could be, I'm calculating for B, you want to calculate what's the max area that's possible. And it turns out to be 42 because you can have a maximum of 6 intervals. And each of those intervals can have a maximum of 7, a height of 7, which was given to us in the question. That's what it means when it says f prime of x is less than or equal to 7. That's saying that the height has to be between 0 and 7 of each midpoint, or each point. Okay, so you take that information and you end up using fundamental theorem of calculus again, and you get f of 6 minus f of 0 has to be less than or equal to 42. You solve that, and you find that f of 6 has to be less than or equal to 62, which means that f of 6 can never be 70 because it has to be less than or equal to 62. Okay, part C gets a little bit easier. You're just taking a derivative, or you're just using the fundamental theorem of calculus, really. So the integral from 2 to 4 of f prime of x, or f double prime of x, is equal to f prime of 4 minus f prime of 2, which equals 1.7 minus 2, which equals negative 0.3. So your answer for 4C is negative 0.3. Part D, you're going to take a limit. You're going to find that it's indeterminate. You're going to use L'Hopital's rule, evaluate direct substitute x equals 0 after L'Hopital's, and then you get negative 8. So part D is negative 8. All right. So now is the time where anyone has questions in the chat. Go ahead and type those away. All right, Peyton says 4B and 4D. Thank you, Peyton. Alexis says 4A. Okay, so if anyone else has any questions, let me know. I'm going to go over 4A and 4B. So if you guys did need help with 4C and D, again, 4C was just using the fundamental theorem of calculus, f prime of 4 minus f prime of 2, basically, which you can just look at the table for those values, so that's not too much. For D, so I know Peyton asked for it, but I'm sure other people missed it as well. Just double check your work. Make sure that your first time you evaluated, you direct subs and you got indeterminate. And then when you took L'Hopital's and you direct sub, you should have gotten negative 8. So I'm guessing for 4D, if you had any issues with 4D, it was probably a math mistake at some point. So just double check your work. As long as like what I'm saying is making sense. 4A, though, is probably the hardest part of this question. So 4A is saying this. We're using a midpoint Riemann sum with 3 subintervals in the table to approximate the value of f of 6. So it's kind of weird how it's worded. We're approximating the value of f of 6. By now, hopefully we're comfortable with this idea that if we take an integral (0 to 6) of f prime of t dt, that's equal to f of 6 minus f of 0. Ignore that. That's using the fundamental theorem of calculus, so that's super important. Whenever we're given derivatives and we have to get back to the original function value, so like if we're given f prime, we have to get back to f, you take an integral, which means you're probably going to use fundamental theorem of calculus. Okay, so that's super important. That's an important first step. Next step is we have to identify what this is. This is the area under the curve of the table. That's what that's representing. We're given the table that represents f prime. So if you're taking the integral of f prime from 0 to 6, that's an estimate for the area underneath the curve. Well, to find the area underneath that curve, use your midpoint Riemann sums. To approximate it. Why am I doing that? Well, because I don't have a function value for f prime, first of all. I just have table. But second of all, it tells me to in the question. It says use a midpoint Riemann sum. So I know the midpoint Riemann sum has a width. Each interval is going to have a width of 2. It's 0 to 6 split up 3 different ways. So 0 to 2, 2 to 4, 4 to 6. My midpoints, which are going to give me my heights, are going to be f prime of 1. Oh my gosh. F prime of 1. F prime of 3, and f prime of 5. You can just look at the table to get all these values. Okay, put this all together into one question. And I get that equals 2 times 3.5 plus 0.8 plus 5.8, which is equal to 20.2. So I'm going to need that information. All right, again, start off by this. I'm going to need this eventually. I need to find what this left side of the equation is. Well, that's just the area under the curve. We're going to approximate that using a midpoint Riemann sum, which has a width of every rectangle has a width of 2, and these are the 3 different heights we're using. So to find the area under the curve, our estimate, we're going to do 2, which is the width of each, times the height of each. And that adds to 20.2, which means that we're left with f of 6 minus f of 0 is equal to 20.2, which means f of 6 minus f of 0 was given to us. They tell us f of 0 equals 20. So f of 6 minus 20 equals 20.2, which means f of 6 equals 40.2. And that's my final answer. So a lot of times you guys will see questions that ask you just to find like a midpoint Riemann sum. This one makes you think a little harder. All right, so moving on to 4B. It's kind of building off of what we just did. So 4B says, all right, so you just found this approximation for f of 6. F of 6 is approximately 40.2. Determine whether the actual value of f of 6 could be 70. So is there any situation where f of 6 could be 70? All right, well, hopefully we're thinking doubtful, right? Because if our estimate was 40.2 for f of 6, and you're asking me if it could be 60, it seems like it's very far off. So I'm already thinking like it's doubtful, but you never know. So let's check it. So we got to use some information that we do know. Part of the information we know is that f prime of x is less than or equal to 7. Again, given to us. It says the first derivative of f satisfies the inequality. 0 is less than or equal to f prime, which is less than or equal to 7. So the heights can't be greater than 7. It has to be less than 7. So based off that information, then the integral from 0 to 6 of f prime of x. Let's figure out what the most amount of area that could be. What's the biggest rectangle we could create with the most amount of area from 0 to 6? Okay, and to do that, we take, all right, well, how many intervals can we have? How many subintervals can we have? Well, the most we can possibly have is 6. Why 6? Because we're given a table that only gives us 0, 1, 2, 3, 4, 5, and 6. Which is, I understand that's 7 total points, but when we're making these intervals, our Riemann sums, our estimates are always going to use only 6 points at most. We can't use every single point. Okay, so this is going to be the most amount of rectangles we can have. Now the question is to find the area, the total area. It's what's going to be the max amount of height that each has. So the biggest width, or the total width, could be 6. The height would be 7, because f prime of x has to be less than or equal to 7. So the height at each of those points has to be less than or equal to 7. So that means the integral from 0 to 6 of f prime of x dx has to be less than or equal to 42. That could be the biggest area that we could have. Okay, well, we know what this equals, though. This is all great and all, but we're asking about f of 6. We're not asking anything about an integral of f prime. So we need to understand this is equal to f of 6 minus f of 0. So really what I have, is f of 6 minus f of 0 is less than or equal to 42. Which means f of 6 is less than or equal to 42 plus f of 0. Which means f of 6 is less than or equal to 62. Determine that the actual value of f of 6 could be 70. We just found the maximum value it could be. The maximum value f of 6 could be is 62. So your answer is no. So you kind of start off by maximizing what the areas can be, or the total area can be, and then that will directly translate to what the difference between f of 6 and f of 0 is. If you're wondering, like, Mr. Harris, how would you come to that conclusion? How do you understand that's the steps? Because this is a problem this isn't like a cookie cutter problem. This isn't a question that I've done in class where I've said, like, these are the steps you take doing. The only way you can solve this problem, and this is why it's designed like this to be on an AP test, is because you have to understand the concept. So remember, they never give you information that's not going to be used. Every piece of information is important. So we knew this f of 0 equals 20 is going to be important, right? But we look at this inequality. This is something that you might glance over, but it's really important. That the first derivative of f satisfies the inequality 0 to 7 of f prime of x. Okay, then you got to ask yourself, what is that saying? And put some information together, like put what you know together. I think the hardest part of this question is this inequality set up here. Is knowing that what is the maximum area that our table can represent. So again, to find that area, the max area, we know that the more subintervals you have, the bigger the value, or the closer. Yes, I guess in this case, the bigger the value, the better the estimate we have. So if I know that I have most 6 subintervals, I'm going to use that to max out my area. 6 subintervals. And I know that the height of each of those subintervals, whatever, I don't care if it's midpoint formula, I don't care if it's right endpoint or left endpoint, it doesn't matter. All of those heights, the maximum they can be is 7. So at x equals 0, f prime of x, the biggest it can be is 7. At 1, the biggest it can be is 7, and so on. Okay, so that's question 4. Feel free to stop by or email me if you have any more questions on that, if that's giving you a hard time. Today, what's on the agenda? Today we're going to do question 6. So the last question of this. We're skipping 5. 5 is That is something that we did not need to do. It's not going to be on your AP test. That's on Unit 8, so we're going to gloss over it. So I want you guys to go to number 6, and then go ahead in the chat, let me know when you're ready. Okay, looks like you guys are ready. All right, so it's going to be 6A. Take a look at this question. Make sure I'm okay. All right, so it says, for 0 to 6 seconds, the screensaver on a computer screen shows 2 circles that start as dots, and they expand outward. If you want, you can draw a picture. For time purposes, I'm not going to, but also like in your case, for your time purposes, it might be useful, it might not. To me, this type of question, usually I like to draw a picture if it's some sort of real-world situation that's modeling geometric shapes, which this one is. It's 2 circles, but there's really no great way to show it. It's up to you. Okay, I'm not going to bother. So that's all they give us. Not very much information at all. So that means we're going to get some information during the questions. So the first question, 6A, says at the instant that the first circle has a radius of 9, the radius is increasing at a rate of 3/2 centimeters per second. Find the rate at which the area is changing at that instant. Okay. So let's break down what we know into some variables. So I'm going to switch over to my camera. All right, let's break down what we know. At the instant that the first circle has a radius of 9, r equals 9. That's what that wording means, right? Radius equals 9. The radius is increasing at a rate of 3/2, which means r prime equals 3/2. A rate of increase of radius is r prime. Find the rate at which the area is changing at that instant. The rate at which area is changing is given by a prime. So we're given radius prime. We're looking for a prime. If I'm looking for a prime, this is what I'm ultimately looking for. That means I first need to start with an equation for a. Well, these are circles, right? What's the area of a circle? It's pi r squared. To find a prime, I take the derivative of both sides. So I get a prime equals 2 pi r times r prime. Why am I multiplying by r prime? Implicit differentiation. This derivative is being taken with respect to time, not with respect to radius. Okay, now I plug in what I know. I know r equals 9. And I know r prime equals 3/2. So I get a prime equals 2 pi times 9 times 3/2. Which means the rate of change of area is equal to 27 pi centimeters squared per second. The unit comes from the fact it's a rate of change, so it has to be per time, right? In this case, time is judged by seconds. And the normal area is calculated as centimeters squared. So that's why centimeters squared is the beginning of our unit. Alright, so go ahead, if you guys have any questions on 6A, go ahead and type that. I think it's really important we do that, what I started with, that piece on the left. So if you can do the piece on the left, you know if I have to get A prime, I need to start with A. It's the only way I can get to A prime. So that'll help you with your initial equation and then taking the derivative. It's a pretty important step. So if you don't have any questions, just tell me you're good. All right. So here's what I want you guys to do. I want you guys to do 6B. So I want you guys to do 6B and then type your answer once you get it. So I'm gonna let you guys get a little free reign here. So the question says the radius of the first circle is modeled by W of t, where W of t is measured in centimeters and t is in seconds. At what time is t, is the radius of the circle, increasing at a rate of 3 centimeters per second? So use that information. We're given a radius, and we want to find a rate of change of the radius. So think about what that means, what you would have to do. If you get stuck, just type in the chat, I'm stuck. So I have an idea of when I can get back to the class. Remember, on the AP test, you will have a calculator. This question, you're not supposed to use one. So I would suggest to try to not use one. If you do use one, that's okay. As long as you get the answer correct, that's what I'm looking for this problem. So challenge yourselves by not using one, but if you need to, go ahead. So guys, I'm going to stop us in 2 minutes. I think that's going to be the most amount of time you need for this question. So if you don't get an answer typed in, it's okay, but just so you know. Yeah, so Peyton, it looks like you're close though. Looks like you have something went wrong, but it doesn't look like it was a really huge thing that went wrong. Okay, one more minute, guys. Good job, Haber. Okay. Good job, guys. All right. So we're making some progress. So I gave you kind of that timing because I want you, again, we're treating this like as if it was an AP test. It's about all the time you would get for this problem. So if you didn't get it done by now, got to work on getting a little bit quicker. So 6b, first things first, like I talked about. We're given the radius of a circle. The question asks, what time is the radius of the circle increasing at a rate of 3 centimeters? So the actual question says, at what time is the rate 3 centimeters? So to find the rate of the radius, we have to take the derivative. So to take the derivative of this, 12 turns into 0. Derivative of 12 is 0. Derivative of negative 12e to the negative 0.5t, you have to use chain rule. So you multiply by negative 0.5 out front. And the e to the negative 0.5 stays the same. So you end up getting 12. Negative 12 times negative 0.5 is 6. So that's where 6e to the negative 0.5 comes from. Now the question actually asks, when is the rate of change of the radius, which is w prime, equal to 3? So when does 3 equal 6e to the negative 0.5t? And on our actual test, stop there, put that in your calculator, and then t is going to be equal to 1.386. So this was your actual exam. It'd save you a bunch of time because that's it. You'd be done. When I say put into your calculator, what I mean by that, again, is you would graph 3, you would graph 6e to the negative 0.5t, you would make your window 0 to 6, and you just find the intersection point, which you get this answer. Some of you guys went a little bit further, and you end up getting divided by 6, so you got 1/2 e to the negative 0.5t. Took the natural log of both sides, so natural log of 1/2 is equal to negative 0.5t. And then divided by negative 0.5. But you could have also done this. So remember logarithm rules. I can rewrite this as natural log of 1 minus the natural log of 2 equals, I'm going to make it negative 1/2. Negative 1/2 t. This is 0. Natural log of 1 is 0. So you have negative natural log of 2 equals negative 1/2 t, which means 2 natural log of 2 equals t. So these two are equivalent answers. Remember, even if you had something like, if you were divided by negative 1/2 here, like that would have also been acceptable. So there's a lot of different ways you could have wrote your answer. Okay, since we're pretty low on time, I'm just going to do 6C on my own. So just follow along as I go. We'll do it as a class. So it says a model for the radius of the second circle is given by the function f from 0 to 6. The rate of change of the radius of the second circle is given by f prime. So we're given f prime of t equals t squared minus 4t plus 4. Based on the model, by how many centimeters does the radius of the second circle increase? So if we're looking at about radius increasing and how long it increases by, that's kind of the same thing as displacement or distance, right? So we're looking for distance actually, which is interesting. So if we're looking for distance, guys, we're given what f prime is. To find distance, you take the integral of f prime. What would my bounds be? Well, it says what's the displacement, or what they say is how many centimeters does the radius of the second circle increase from 0 to 3. Right, so if f prime of t is the rate of change of radius, that means f of t is the length of the radius. To find the total length it grew, you take the integral from 0 to 3. Okay, and so what this is equal to is the integral from 0 to 3 of t squared minus 4t plus 4. Again, you have a calculator, you can just use your calculator. This one's not too bad though, so I'm going to actually take the general antiderivative, which is 1/3 t cubed minus 2t squared plus 4t between the bounds 0 and 3. Remember, this would be 1/3 times 3 cubed minus 2 times 3 squared plus 4 times 3. That entire red quantity minus 1/3 times 0 cubed minus 2 times 0 squared plus 4 times 0. So that's using the fundamental theorem of calculus. First take the general antiderivative, which is 1/3 t cubed minus 2t squared plus 4t. Evaluate at each endpoint, take the difference. So I'm just plugging in 3 for t minus plugging in 0 for t. And that gives you 3 centimeters. So the math you can see isn't too bad, especially with a calculator. It's not bad at all. Like we'd have on a test, we would have a calculator available to us. So like that part's really pretty simple. The only difficult part is trying to rationalize what the question's asking. If we're given a rate of change of the radius, to find the actual length or the actual radius was, you would take the integral to reverse that process. Given a bounded integral, that's going to give us a length over a distance. So the radius length from time interval. So in this case, obviously, it's from 0 to 3. All right, so you guys, about 3 minutes. Any questions you guys have, go ahead and ask them. If you guys don't have any questions, go ahead and like the stream, obviously. You're good to go, though. Thank you for stopping by. I'll be back on Wednesday. Make sure you start your homework tonight. It's 2 questions. Shouldn't take you crazy long. Shouldn't really take you long at all. So Try to do these, as always, try to do them on your own. Try to get through them as much as you can. This is really good prep for your test. And I'll be available. I'll be back on from 1 to 2 for my office hour. And I will be answering any questions through email or my office hour. So just let me know. Andrew, did you find the integral of the given equation because you were given the bounds and f prime? Exactly, Andrew. And not only that, Andrew, so I was given the bounds, you're correct. I was given what f prime was, also correct, which was a huge giveaway. But the biggest thing is that the question asked for just the radius, length of a radius. So I knew I was looking to get back to f. So if I'm given f prime and I'm given a bounds, to get back to f, I know I have to take an integral. You too, Aber, thank you. So that's where kind of my thought process was with that question. If you're given a rate of change, you have to get back to just the total amount. You always take an integral. Andrew, I don't know if you're still here, but if you are, I saw your email this morning. Once the streams are over, I'll answer your email. Looks like you're having some problem with College Board. I don't know exactly. So, again, I don't know if you're still here, but if you are still here, the College Board, it can be kind of weird. It's not always the best. I haven't heard it from anyone else, so I'm guessing it was something on your end. Just make sure your Wi-Fi is good and make sure you have any updates to your computer you need. And if you have to, just restart your computer. Good morning, Digidio. Sarah, how was your weekend? Morning, Jaden. Appreciate you guys asking. It was good. I made wings for myself yesterday. I had some sauce from BW3s that I really like. So that was really good. Very happy about that. Got to talk to some friends. Just a usual weekend. Got to catch up on some sleep. Watched the Michael Jordan documentary last night. I've been doing every Sunday. Love that. Very, very good stuff. So yeah, it's pretty good. Jaden, how was your weekend? Pretty good. Rode 29 miles on my bike in 2 days and still painted my house. Wow. It's impressive, Jaden. 29 miles on your bike. Where do you usually ride? What, do you have a path in Vermilion you go through? Do you just ride around like neighborhood in circles? What's usually your route? If you're an Algebra 2 student, guys, go ahead and let me know. Looks like I got 4 people. I know Sarah and Jaden are here. Everywhere. All over Vermilion in my neighborhood in Mill Hall, everywhere. That's awesome, Jaden. Good for you. I'm not a huge biker. Not really a huge runner either. I don't like, I guess endurance, long distance stuff isn't my forte. I love biking. Like I really love biking on like paths, like going like mountain biking and stuff. I really enjoy that. It's hard work, but it's really fun. Cool sights and stuff like that. But like riding around town isn't really my favorite thing to do in the world. I like to be in like scenic routes. Like I went on vacation to Colorado this past summer. Colorado's got some beautiful terrain, and my buddy and I went on a bike trip. Like we probably biked 20 miles. We were all over the place, but we had a lot of fun with that. So yeah, Jane, if you're really interested in that, I recommend going out west. West has some really good places you can bike. Country roads, yeah. Very cool. I'm glad. Good to hear you're getting out and getting exercise and enjoying the weather. It was really nice this weekend, like really nice. But unfortunately, it's getting a little bit chillier. I think this week and a little bit rainier, which kind of stinks, you know. Happens though. Okay, so I'm gonna get started. It looks like we only got 3 people. So I know Sarah and Jaden, you guys are here. I don't know who the last person is, so I guess I'm gonna kind of treat it like just you two. So happy Monday. I'm gonna go over the calendar and then we can get started. So usual schedule, nothing's different. Keeping us on this schedule. There is gonna be some information just so you guys are aware. It looks like there's gonna be some information about school and the end of school and how this is all gonna work. I don't know what is true, what's not true, what I can say, what I can't say, whatever, but what it seems like is that I know our last day of school is June something, June 10th maybe. I think it's going to end a little bit earlier, so like at the end of May, it'll be the end. And then it'll be just a couple weeks for like makeup work. So that's what it sounds like. It sounds like it's going to end like May 27th, like somewhere late May. You guys will like, I'll be done streaming, I'll be done assigning. Like there'll be no more assignments. Maybe that's the wording I'm looking for. I won't be giving you any homework assignments or doing any teaching after like May 20 something. I know we have a meeting today, so I'm gonna hear more about it. But just so you guys know, maybe it's something to look forward to. Yeah, Jay and you and Sarah are always here. You guys, I can rely on you guys. But maybe it's something you guys are kind of look forward to a little bit. That school might, I guess, theoretically, because you guys, I guess for you guys, since you're on top of your stuff, you're getting your work done, you're paying attention, you're showing up to the stream, and I'm sure your other classes the same way. So because you're doing this, I think you guys might get rewarded and be done a little bit earlier with school. So summer might start a little bit sooner for you, as long as you stay up on all your assignments. So that's my Mr. Harris recommendation for you guys. I'm sure you'll get a phone call or an email or something. You'll hear more about it once it's finalized. But Yeah, I commend you guys. Keep it up. So with that being said, though, I like the pattern we're in. I like the how we're handling this in terms of this algebra. Like I feel like it's been pretty good, conducive atmosphere. Sarah, can we do a Zoom for last day? Yeah, I think we can do a Zoom. I have to figure out how to use it. Like I don't have a license to, but I think I can just do like a free. I don't know. I'll look into it, Sarah. I'll tell you that. We'll stick with that. I'll look into it. I would love to. Yeah, so we'll see. I'm gonna try my best to figure out if that's doable. Remind me when we get closer to the date. So yeah, this week I like this. I like this thing we're doing. I like I'm still our rule is that math is Monday and Wednesday. Every other class, well, math and science are Monday and Wednesday. The other classes are Tuesday, Thursday. So that pattern's not changing. I'm still teaching Mondays, Wednesdays. All your math should be done on Monday and Wednesday and Friday. We're going to be doing 8.6 exclusively for the rest of this week and probably beginning of next week too. We're going to do 8.6. So today is going to be just general rational equations, solving rational equations. That's what we're going to be entirely focused on today, and your Alex will be entirely focused on that as well. On Wednesday, we're going to be focusing on rational equations that have to do with real-world problems. So we're going to take a look at about 3 different real-world problems on Wednesday, and then the homework will kind of, highlight those. And then Friday, review day, as always. So your homework assignments are Alex and a page out of the book that will be assigned on Google Classroom. And then next week, we'll continue 8.6, and we'll do inequalities. So we'll be solving rational inequalities. And honestly, I'm going to look into it a little bit. I'm going to talk to Mr. Snook because he also teaches Algebra 2, obviously. So I'm going to kind of get his input on it. But like in my personal opinion, I think I might actually do 8.6 all of next week as well. Because I think this is a super important chapter, first of all. But also there's a lot to it. So I think maybe we'll do inequalities Monday for sure. And then Wednesday, maybe I'll just do an entire, like a review of all of it, potentially. I don't know yet. Future Mr. Harris figures all that out. Okay, so without further ado, let's get started in our notes. So I want you guys to turn to page 570. Turn to page 570. These are going to be your notes, 8.6, solving rational equations. And inequalities, if you want to put that as well. But we're not getting to inequalities quite yet. So yeah, go ahead and let me know when you guys are good. Got that on, ready to go. Got your notes open. Did you have your cup of coffee yet today, Jaden? I'm gonna tell you something. I don't know if you're gonna like this, Jaden, but I figure if I'm gonna tell anyone, I gotta tell you. I've been trying not to drink coffee. I've been straying away from coffee a little bit. You may ask why. Why, Mr. Harris? Why would you do such a foolish thing? And I'll tell you why. Because coffee for me, coffee's good. I don't dislike it. But it's just not something that like I don't drink coffee for the taste. I don't drink it because like I'm like, man, like I just want to flavor something in the morning. So coffee did. Like that's not how I roll with coffee. I drink coffee because I need it for energy. Like it gets me through. Now, the way the schedule has been, I don't know about you guys, but like the way the schedule has been, I've been very refreshed. Like I haven't been very tired. Because there's days like Tuesdays and Thursdays, because I'm not waking up to stream, I can sleep in until like 10 o'clock, which is fantastic. So like I wake up refreshed, ready to go, take on my day. I don't need coffee, Mondays, Wednesdays, and Fridays are a little different because I have to wake up a little bit earlier, but I don't know. I think just like I'm not moving around. Like at school, I would drink coffee because I'd be moving around constantly, like walking around the hallways, walking around my class, always standing up. Like my body was exerting a lot of energy. To stream, I just sit here. I don't get up. I don't move. I just sit here and write. So like I don't have anything that's like wearing me out and making me more tired. Plus, I'm talking all the time when I stream. Like I'm just like listen to me right now. I just keep ranting. So I'm never not talking. And I'm not gonna like get tired in the middle of me talking. I know you guys probably fall asleep while I'm talking, but like it's hard to be a person in the middle of like talking and then you yourself fall asleep. So yeah, I guess moral of the story is I just haven't needed coffee, which means that I'm not going to drink it if I don't need it. I don't know, coffee I just don't feel like is always the best for you. I think there's some benefits to it, but I think it messes up your stomach a little bit. Kind of affects you for the rest of the day. I don't like you get that bad breath too for the rest of the day. Yeah, I don't know. That's kind of my take. What I want to start doing is drinking smoothies. That's what I want to start getting into. I've just been drinking a ton of water. That's about all I drink. But I would like to get into drinking smoothies because that's good protein, number one, but also it's a good energy booster too that's not coffee. All right. Sorry, I figured I'd tell someone about that. I know Jaden would be interested. Jaden's a coffee guy. So let's tackle this lesson here. All right. So top of page 570. I like to read this stuff. You know I do. So I'm going to read it to you guys. We'll talk about it a little bit. So they got a gaming club. A gaming club charges $20 per month for membership. Interesting. I don't know. If Mr. Harris started a gaming club at Vermilion High School, you think people would pay $20 a month to be a member? I don't know. I don't even know if that's allowed, first of all, but it's interesting. I guess it makes sense if you're buying new games. Members also have to pay $5 each time they visit the club. Oh, okay, so this is like an actual like real world all right, this isn't just like a student. So I saw the picture of these kids playing. I thought it was like kids. This is like an adult thing too. Man, so there's an entry fee and a membership fee. That's crazy. So it's really 25, or no, you're paying 20 a month, but 5 times each. Okay. If a member visits the club X times in 1 month, then the charge for that month will be 20 plus 5X. That makes sense, right? You start with your initial cost, 20. X is the number of times you make it there, and you have to pay 5 each time you get there. So 5 times X. The actual cost per visit will be 20 plus 5X divided by X. So why is that? Well, if 20 plus 5X is the charge for that month, you have to make that charge every single time you visit. So 20 plus 5X divided by X. To determine how many visits are needed for the cost per visit to be $6, you would need to solve the equation 20 plus 5X divided by X equals 6. Cool. So yeah, they kind of set up this idea of like you're paying this your fee each time you go, which is 5X. X is the number of times you go. To break up the cost, you have to divide your total divided by the amount you go. All right. So this is our introduction because it's just telling you like how in the real world you can get to these equations of rational functions. Like how do we get to the point where we would need to solve a rational equation? This is an example of how you could get to that conclusion. So, like I said today, for the next 40 minutes, we're going to focus strictly on just solving rational equations, how we can do that. They're all the same. I mean, they're not the exact same, but like the general idea is all the same. And it's taking concepts we've been working on the last few weeks. So let me ask you guys this in the chat. What has been the most important step in simplifying rational expressions? So a little bit review time for you 5 people who are in here. Last I don't know, probably 2 or 3 weeks we've been doing rational expressions, right? So my question to you is, ever since we started rational expressions, we started by simplifying them. What was the most important step when we were simplifying rational expressions? We've done all this simplification, giving us like a rational expressions, could be a sum of rational expressions, difference, whatever it may have been, and we had to simplify it. What was, I mean, you don't even say what, just what, name some steps. Oh, so you guys are all talkative, and then when I ask a question, everyone gets quiet. I don't know if I should be worried because no one knows what to say or have any sort of response to it. There we go. Now we're talking, Jaden. Having the denominator be the same. Very good. Get a like denominator or a common denominator. Awesome job. That's what I was getting at. When we're simplifying these rational expressions, what we've had to be doing is getting like denominators or common denominators. We had to do that every single time. And that's not changing. So when we're solving rational equations, we still have to get a common denominator. Remember, we did that because when we got a common denominator, we could add and subtract rational fractions, which is important. We want to add and subtract them. In order to do that, we need a common denominator. All right, very good. So, equations that contain one or more rational expressions are called rational equations. These equations are often easier to solve once the fractions are eliminated. Very big. You can eliminate the fractions by multiplying each side by the least common denominator. All right, so this brings it all together. So what Jaden was saying. So here's how we're going to solve a rational equation. Based off of whatever we're given, we're going to first get a common denominator, a least common denominator. That's going to be our first step. So we have to start with that. And then from there, we're going to be able to simplify the equation. So let's take a look. Best way to do it is take a look at an example. So page 570, number 1. It says to solve 4 divided by x plus 3 plus 5 divided by 6 equal to 23 divided by 18. All right, so just like adding, subtracting, and simplifying rational expressions, to solve rational equations, we need to first find the least common denominator. And when I say that, I mean the least common denominator of every single fraction. The goal is to put the same denominator underneath all of these. I'll show you why in a second. So what do we do? Well, x plus 3. None of these have x plus 3. So I know x plus 3 has to be a part of my least common denominator. Then I have a 6 and an 18. Which one of those is the least common? 18. Because 18 goes into 18 one time. 6 goes into 18 3 times. So my least common denominator is x plus 3 times 18. Now we rewrite all these fractions. Every single one of them is going to be over x 18 times x plus 3. So I'm just going to write this ahead of time. You don't have to do that. That's just kind of how I like to operate. So from here, we figure out how do we rewrite these fractions. So how do we go from 4 over x plus 3 to something over 18 over x plus 3? How did the denominator change? I multiplied it by 18. So I need to multiply 4 times 18, which gives me 18, 36, 54, 72. To change 5/6 into something over 18 times x plus 3. First of all, I need to multiply by x plus 3, so 5 times x plus 3. And I also need to get from 6 to 18, I need to multiply by 3. So I would also multiply by 3. So 5 times 3 times x plus 3. For the last fraction, 18 is in my denominator already, so I need to multiply everything by x plus 3. So I get 23 times x plus 3. Okay? Oh, I'm so sorry, Jaden. Good call. Here I was thinking I was showing you everything. Apologize for that. All right, let's go back. So this was given to us to solve that least common denominator. I'm just looking at what these all can multiply into. X plus 3 has to definitely be in there because that's the only denominator here. 6 and 18 are multiples of, well, 6 goes into 18, so 18 would be my other part. Again, to get 72, it's 4 times 18. To get 5x plus 3 times 3, 5. 6 times 3 gives me 18, so 5 times 3. And then you still need the x plus 3. 23 already has 18 in the denominator, so all I need to do is multiply it by x plus 3. Apologize for that. Now, you don't need to show this step, but again, I'm going to take it one step further. I'm going to make this left side all one fraction. So 5 times 3 is 15. So 72 plus 15 times x plus 3 divided by 18 times x plus 3 is equal to 23 times x plus 3 divided by 18 times x plus 3. Again, not totally necessary, but I did this on purpose. I wanted to show you something. Look at this now. I have one fraction here, one fraction here. If I multiply both sides by 18 times x plus 3, think to yourselves, what happens? Let me ask in the chat, what happens? Jaden, be a little more specific, because there is an equal sign, I agree. But what becomes equal? Like, what happens to something? Yeah, the two expressions do come equal, but what I'm looking for, the answer I was looking for, is that the numerator and denominator cancel. If I multiply by 18 plus x times x plus 3, those cancel, and same thing on the right side. So I'm left with 72 plus 15 times x plus 3 equals 23 times x plus 3. That is so important. That's the most important step. Why is that so important? Is because we can't solve for a variable. The question says to solve. That means solve for x. We can't solve for x when it's in the denominator. We have to get it into a numerator, and we have to get rid of the denominator. So if you want to make a note somewhere in your notes, to solve rational equations, eliminate denominators. So that might be like a useful note for you to jot down. Help you remember whenever we're solving rational equations, we have to always eliminate the denominators. Because we can't, if there's still if there's a variable in the denominator, it's stuck there. We have to get it out of the denominator to solve it. So hopefully this part, not too bad. Distribute 15 and I get 15x plus 45. Distribute the 23 and I get 23x plus 20, 40, 60, 69. Then I need to solve for x, so I'm going to start combining. So I'm going to combine 72 and 45. 72 plus 45 is going to be 117. 23x minus 15x is going to be 8x. 69 will keep on that side. Then I subtract 69, and I get, I'd have a calculator. I'm not even going to try to mess that up. I get 48. (48) equals 8x. Divide by 8, you get x equals 6. That's your final answer. So in the chat, let me know. How's that look? Do you need help? Do you need clarification? Does that look okay? Is there a step that you didn't make any sense? What do you guys think? Jaden says, little confusing in the beginning. Be specific, Jaden. What's confusing? What step? So if you can explain how to do the first part about setting the problem out, that would be great. Okay. So I think, if I'm following correctly, I think what you're looking for is just this first step. All right, so this was given to us, the solve part, obviously. That's the question. Very first step is to find the least common denominator. Just like that's what your answer you gave me, Jaden, right? You said what was the most important step, and it was always to get a least common denominator. So that's what I did. So I found my least common denominator was x plus 3 times 18, because that's what they can all have in common. That's the smallest number they can all have in common. Because we know they have to have x plus 3 because that's its own by itself. None of them have that. So they know they have to have an x plus 3. I know 6 goes into 18. 6 times 3 gives me 18. So I know 18 also has to be as my least common denominator. This next step, so going from here to here, the original question to here, was just using my least common denominator. So remember, I can't change the equation. I can't change numbers, which means if I'm just going to randomly decide that I need to change the denominator into 18 times x plus 3, I have to multiply the numerator also by 18. So that gives me 72. If I want to magically change the denominator to 18 times x plus 3 here, well, I have to multiply 6 by 3 and by x plus 3. So that's why you get 5 times x plus 3 times 3. To get the denominator for the last term, right, I had to multiply by x plus 3. Again, I have to do that to the numerator and denominator, so I'm not changing the value. So the numerator also gets multiplied by x plus 3. That's how you set up the problem. So go ahead, Jaden, in chat. Let me know if that sounds good. Does that make sense? Are you okay with that? Is it better? Worse? It's about the same? That helps a lot. Okay, cool. All right. So here's what I want to do then. I want you guys to do guided practice GP 1 capital A. I'll let you guys do that on your own. Give you about 5-7 minutes. Go ahead and do that one on your own. Remember, just get a least common denominator first. And go ahead, guys, type your answer too when you're done. Jaden, good job. X equals 2. I don't know who else is, I don't know if anyone else is still, looks like I have more people. I don't know who's working on it though, so I'll give it a second, about 2 more minutes. Write down the question. Okay, let me go over this. So least common denominator is your first step, like I've been saying. that's very consistent to these rational expressions. Think least common denominator. To find that, x plus 3 again on its own. So we know that these have to share x plus 3 because they don't have any x's or any sort of factors. So x plus 3 is definitely in there. 2 and 10, the least common multiple of 2 and 10 is 10. Because 10 times 1 and 2 times 5. And that's it. So that's our least common denominator. Which means our new expression is going to be 2 times 10, which is 20, divided by 10 times x plus 3, plus 3 times 5, 5, 10, 15 times x plus 3, over 10 times x plus 3, equals 19 times x plus 3, divided by 10 times x plus 3. So again, you notice that now all my fractions are going to have the same denominator, which is huge because now I can get rid of all the denominators. If they all have common denominators, that means that 20 plus 15x plus 3 equals 19x plus 3 has to be true. If the denominators are all the same, then the numerators have to be equal. So the expression of the numerators have to be equal. So you can see in my case right now, Jaden specifically, because you're the only one I know is still listening, it doesn't really matter your denominator, or you don't need to show that step where you're like combining them and then canceling the denominator out. Okay, I know what you're doing if you go from here to here. All right, and then I think you guys are pretty good with this. So you end up using algebra. If you got to x equals 2, then you probably got through it. If it's an algebra issue, then I recommend let me know first of all, and I'll go through it if it needs to be. But if not, just get some more practice with solving just general equations. You're in Algebra 2 though by now, so you should know how to do that. That shouldn't be an issue. Distribute, combine like terms, solve. And you get x equals 2. Well done. All right, Jaden, since again, you're the only one I know is here. Anyone else is here can please participate. But my question is, when do we know that there's an extraneous solution? Or how do we know when there's an extraneous solution? That's my question to anyone who would like to answer it. What is an extraneous solution? How do we find it? What are we looking for? What does it have to do with? There you go. And Jaden, so you actually don't even need both denominators. So I'm glad you said that. It's actually only a single denominator. So if there's any denominators in your solution that, or if there's any denominators in the original equation that your solution makes 0, that's an extraneous solution. And that's what we're going to get into next. That's going to be the nuance of the next problem. So these are just kind of the last two we did were just kind of generic. This one's going to be a little bit different because this one has to do with rational expressions that have quadratic equations in them. All right, so I'm going to look real quick. You take a look at my screen. I'm on this one, Jaden. So example 2. Multiplying each side of an equation by the least common denominator of rational expressions can yield, results that are not solutions of the original equation. These are extraneous solutions. So yeah, like I said, I think, or like you said, Jaden, I think we're on a pretty good, you have a pretty good idea of what that is. Okay, so example 2. Same idea, we're solving for x, and we're given this equation, 2x over x plus 5 minus x squared minus x minus 10 divided by x squared plus 8x plus 15 is equal to 3 divided by x plus 3. All right. So I made a note here. These are all rational expressions, but the middle rational expression has quadratics, quadratic equations, or not equations, quadratic expressions. Whenever we have quadratics, so I said with quadratics, factor first. So whenever a question has quadratics with it, I don't care what the situation is. I don't care if it's rational expressions, if it's just quadratics, whatever it is, you always want to factor. Factoring makes it much easier. It gets rid of the x squareds. So that's what we want to do first. I'm taking this down, and I'm going to keep the 2x over x plus 5. Nothing to factor there. This second term, though, there's a lot to factor. So the numerator, x squared minus x minus 10. Let's take the shortcut. Negative 10 times 1 is negative 10. What two numbers add to negative 10 and add to negative 1? Well, you do that in your head, you're thinking, I don't know, right? The only two numbers that, well, there's 4 different factors of 10. 10 and 1, that doesn't add to a negative 1. 5 and 2, that doesn't add to negative 1. So actually, the numerator here, I can't factor. So I'm going to keep it as x squared minus x minus 10. Okay, not ideal, but it's okay. We're managing. We'll be fine. So we can conclude we can't factor that. Let's look at the denominator. What two numbers multiply to 15 and add to 8? 5 and 3. So I can factor the denominator. X plus 5 times x plus 3. Okay, and then the term on the right side of the equation, that can't be factored. Now that we did that, now we can follow our, this is the exact same problem as the last two we did. So we gotta get a least common denominator, which notice they have x plus 5 in them. So x plus 5 is definitely part of the denominator. X plus 3 is the other part. Each one of them, so my least common denominator is the second term's denominator. X plus 5 times x plus 3. All right, so that means that I'm going to have my common denominator for each of these. So in order to get from x plus 5 to x plus 5 times x plus 3, you multiply by x plus 3. So I do the same to the numerator. The second term, notice, I already have the least common denominator. It's already there. So I don't have to do anything to it. I don't have to touch it. I just leave it as that. The last term, I need to get it to x plus 3 times x plus 5, so I have to multiply the numerator as well by x plus 5. So I have 3 times x plus 5. Okay, and now that I have all the same denominators, I can just worry about only the numerators. So I cancel out all the denominators, and I'm left with 2x times x plus 3 minus x squared minus x minus 10 equals 3 times x plus 5. I'm going to give you guys a second just to copy that down. Take a look at it real quick. And if you already did, then go ahead and start trying to solve for x. Well, first things first, in order to solve for x, I need to distribute. So I need to simplify everything. So 2x times x plus 3 gives me 2x squared plus 6x. Distribute the negative 1, so minus x squared plus x plus 10. Distribute the 3, 3x plus 15. I ran out of room, so I'm going to fly to the back real quick. Okay, so flying to the back, just before I do, I need to make sure I can see what's going on. So I have 2x squared. I'm going to combine like terms now. So 2x squared minus x squared gives me x squared. 6x plus x is 7x. Minus 3x is 4x, so plus 4x. And then 10 minus 15 is negative 5. All right, so if you guys go ahead and take your time with that, obviously. I'm just trying to, I'm running out of time a little bit, so I just want to try to get through this. Just distributing and combining like terms, this is what I'm left with. I set it equal to, because if we want to solve for x, right, we set it equal to 0. Okay, now let's solve. Well, how do I solve a quadratic? I factor. All right, you could use a quadratic formula as well, or completing a square. But personally, I'm going to factor because this one's easy. Two numbers that multiply to negative 5 and add to 4. Positive 5 and negative 1. So I get x plus 5 times x minus 1 equals 0, which means x plus 5 equals 0 and x minus 1 equals 0. So x equals negative 5 and x equals 1. Be a negative 5. All right, and that's all. I went through that so quickly because that's review. Hopefully we're okay with solving quadratic equations. Okay, so now, that's great. Like, we did a great job. We got 2 answers. Interesting, right? 2 answers. However, we need to check. Why do we need to check? We need to check because we might have extraneous solutions. Okay, so let's look at the original equation. And I'm going to plug in. So check x equals 5. So I'm going to plug in negative 5 into my original equation. You don't need to do all this work. So if you're following along, you don't necessarily need to do all this work. I'm just showing you what I'm doing. I'm plugging in negative 5. In fact, this is all a little unnecessary. But I just want to show you what I'm looking at. Okay, here's why I did that. Because notice this denominator right here. That denominator right there is equal to 0. Negative 5 plus 5 equals 0. So, x equals negative 5 is extraneous. Which means I'm actually crossing that out. That's not a solution. That's an extraneous solution. There's an asymptote there, we call it, a vertical asymptote. So it's really important we check. We would also check x equals 1. I'm not going to go through that, but you end up getting 3/4 equals 3/4, which is good. So x equals 1 is definitely my solution, my only solution. So whenever you guys have multiple solutions, if you have any, I mean, I should have done this for the first question. You should always check your solutions. And what you're checking for is just the denominator. That's all we care about. I don't care what the numerators say. It can be 7,000. I don't care. All I need to see is does the denominator, as long as my work was correct, it'll turn out into something like 3/4 equals 3/4. If my work was correct, that'll always happen. The only thing I need to be careful for is there a situation where my solution might make a denominator in the original equation 0, which in this case it did at x equals -5. So I know that was a lot going on there. I know I took it kind of quick at times, slow at times, but this was out of the book, so you can see there the way they solve it is a little bit different than mine, which is perfectly fine. It's up to you at the end of the day. I like the way I do it a little bit better because I think it organizes the work better than the book does. But if you want to like go through back with the book's example and maybe that might clear some things up as well, just let me know. No, I feel pretty good about this. Okay, very good. Well, I'll still be on for the next 4 minutes, but because Jay and you're the only one who's talking. So if you're good, then I'm good right now. If anyone else wants to speak up, go ahead and do it now. I'm more than happy to help out. So if that's the case, then Jaden, have a great day. That's all. I'm not gonna make you do anything else. Check out that Alex assignment. I would do it, as soon as possible. If you can do it now, start on it now. It's good to that's fresh in your memory, so you should be able to fly through the Alex. I think there's like 9 questions. I'll be back on 1 to 2, guys. So any questions you have, you need to get answered in person rather than email, please stop by. 9 questions, Jaden. Obviously, I'll always answer emails. So if you can't make the stream, don't worry about it, or the office hour stream, don't worry about it. Just email me. I'm pretty much answering emails up until 9 o'clock. Then I'm not allowed to legally. So if you email me past 9, don't feel it's because I hate you. I probably see it because I'm up pretty late usually anyways. I can't answer you. So I try to answer you the following day. Just to understand. I'm sure most of you know that by now. But, I have office hours. I call them 1 to 2, 2 to 3. Like I prefer all questions get asked in that time frame. But I'm pretty good about helping you guys out pretty late into the evening for the most part. Can't guarantee it, but I try to. Have a great day, though, guys. It's been fluctuating. My viewers have been going from like 3 to 7 at any given point, so I don't know who's hopping in, who's hopping out, who's listening, who's not listening. But hey, hope you guys are all doing good. I miss my students, miss my Algebra 2 people. Yep, thank you, Jaden. See you Wednesday. Guess I'm going to get off. Have a great day, everyone.